Compression is the art of taking something and trying to minimize it by removing unnecessary details or by looking for repeating patterns and replacing them with smaller things. Compression is needed in many walks of life, for example, when you make videos. This video is going to be about 60 gigabytes, but when I painstakingly go through the entire video and remove unnecessary parts like somewhere when I'm sneezing or when I get a call, basically, I'm removing distractions and unnecessary parts from this content. And generally, by the time I'm done editing the video, it becomes about 4 to 5 gigabytes. And then if I'm using a good video editing software, it will remove some fine details from each frame of the video and reduce it to an even smaller size. So after I render this video, it will be not in gigabytes, but in a few hundred megabytes. And that is way too large in itself as well. If you were watching this video on some shitty website, it would cost you a lot of money and this video would take a heap ton of time to load. And so websites like YouTube use their own compression systems to further reduce the video into a few megabytes. Tom Scott actually has a very great video talking about how YouTube does it. I'll leave a link in the description or in the cards. So yeah, in this video, we are going to be making a compressor for test documents using simple HTML and JS. And if you want to show support for this kind of content and want to learn how to make cool things all on your own, subscribe to this channel. And if you've already subscribed, thank you so much. You give me a reason to keep growing and making content to help others grow as well. Also, there's going to be an announcement at the end of this video about something I've been working on for about like half a day. It's not a paid course or anything like that. Also, I'm going to be building this right now, right in front of you. I'll be leaving in all the mistakes I make so that you can reference them whenever you replicate this code or whenever you want to actually learn how to solve problems. But first, let's come to the theory. There are generally two kinds of compressors. One is the lossy kind and one is the lossless kind. For context, we are going to be making the lossless kind. Lossy compressions deal with the removal of fine details that might not matter much, meaning if you had an image of you, the lossy way of compression will reduce the quality of things around you since you're the center point. It also needs to be configured that way, and there's hundreds of ways to make lossy compressions, and people do that all the time as well. Lossless compressions, on the other hand, work like this. Say there's that image of you. An image generally is just a large array of color values. So lossless compression will take a look at the first color and then start moving forward in that array. While it's moving forward, it will count how many times the color repeats itself till another color appears. And then instead of storing that color multiple times, it just stores how many times it repeated and the color's value. So say if the array looked like this. Now the compressor will take a look at the first color and see how many times it's appearing. In this case, it's going to be 3. And then it will just store green 3 and then do that throughout the entire image. We will be doing something similar. We will make a log of all the special words in our sample text and store just the index values instead of the entire word. So let's jump straight into the code. I have an index.html file and an index.js file. The first thing you want to do is create your boilerplate code. And in this boilerplate code, we'll have the app. And first thing we need inside the app is a h1, just so that we know where we are going with. And you can name it whatever you want. I'm going to be going with, this is dummy text. And now we need a paragraph of some sort. So I'll make a div called .inp class. And I'm going to just steal some text from the Bible because there's a whole lot of repeating terms and stuff like that. And it's just easy that way. So I already have that. And if you don't want to use this, you can always just do lorem ipsum. The way you would do that is if you're using VS Code, just go onto a line and then write lorem, and just write the number of words you want. If I want 100, just write 100 and press enter. That will generate 100 words for you in lorem ipsum. The thing with lorem ipsum is that it doesn't have too many repeating words, so it's not that common. English is mainly where your compression is going to be at anyway, and since we're using compression in English for our experiment right now, it's better to have the Bible. Well, now that we have our dummy text, let's do another h1. And I want to see some stats about the compression and about the dummy text and stuff like that. So let's do stats. Let's make a div called stats as well. And in here, we'll have a few divs with different classes. The first one will be called OG for original, so the original text. What we will be wanting in the OG class is going to be how many letters or characters are in our text. So dot OG. Yeah, so let's make a class for number of words as well. So I'll just call it NOW. Also, let's make a class for number of all special words. So NOS. We also want to see the final size after compression, so let's do that. Dot final size. And then we also need to see the total reduction in both numerical value and percentage, just to be sure and just to see if things are working. So let's do TR for the regular reduction, and then dot TRP for the percentage. And that will be generally all. We also definitely need a output to see if we can decompress it. So let's just make a class called decompress, or let's make a class called OP. This should work, hopefully. Yeah, let's just give it like another h1, I guess. Let's say decompress. And now let's import the JavaScript. So script source index.js. That looks like it should be all for our HTML. I'm going to open this in the browser now, and let's come to CSS. Okay, so let me align all of this together and then we can move forward. So if you want to write CSS in a .css file, you can do that, but I'm just going to write it over here. Just a personal preference. Let's first select all. And let's set the font size to 1em by default and font family to Arial. That's just something I like to do no matter what. So font size 1em, font family Arial. Let's get rid of the margin as well. Yeah, and coming to the app, let's do display of flex direction column, and align items center. Let's also give it a width of 100%. Let's see what that looks like. That looks fine, yeah. Let's just get rid of the font size. It doesn't really matter. Font family is what we're at. Okay, let's tackle the H1s. Let's increase the font size to about 3em instead of whatever it is right now. Let's give the app some padding. So you should definitely set the box sizing to border box in the select all thing, and that way everything will be contained inside the web page. That's starting to look like something, yes. Okay, so aesthetic wise, let's give the app a background color of something not white. So RGB, let's go with 200. Let's also give it a little bit of padding at the bottom as well. By a little bit, I do mean a lot. So padding bottom of about 10 VH. And that way there'll be a little bit of distance between the edges. Let's come to the .inp. Let's set the font size to 1.3em. Let's also set the background color to white. Let's set the line height as well. So line height of, let's just do like 2em for now. Yeah, now it's actually readable. Let's give it a little bit of padding. Things are looking centered. Let's give the H1 a color of white. Let's see how that looks. No, that is bad, but let's just give it something not like fully black as well. That looks better. Okay, so coming to the stats, let's make that a grid. So let's do display of grid. We'll set the grid template columns to just 1 FR for how many ever there are. Let's give it a grid gap as well of, let's do 1 EM. It's not going to be really visible, so there's not much to see in this sense. We'll come back to that later if anything. Let's set the font size to 1.2 M as well. And let's just pause the CSS right here. We can come back to that later, it doesn't really matter. Let's jump into index.js. And the first thing we need to do is call all the HTML DOM elements we need. So let's start by making that happen. The first thing we need is the input. So inp is equal to document.qes. It was called .inp, I guess. And then let's do variable op equals document.qes .op. I am going to cut it right here. All you need to do is just copy this a bunch of times and then assign the class and change the variable name. This is boring. All right, that should be looking good right now. We also should just directly load the input value. So inner text. Okay, let's console log the INP. And it's working. Now that we have all the elements we need, let's make the compression function. This is going to be a class. So let's do function compressor. And it will have a index file. So this dot index is an array. And then this dot special is equal to an array. The special file is where we will store all the special words or words that appear uniquely. Now the compress function will also have an inbuilt method. I'm just going to call it eat, and all it's going to do is encode our data, and it will take a parameter and we will be compressing that parameter basically. So we kind of know what text we are going to be expecting. And generally speaking, it's going to be spacebar separated values. So let's separate them wherever there's a spacebar. So variable words is equal to a dot split wherever there's a spacebar. Now that we have all the words split into an array, let's go through all of them. So let's make a for loop that goes from 0 to I is less than words dot length I plus plus, and in here all we have to do is run an if statement, which will basically check if the word already exists in the special array. If it doesn't, put it in. So if this dot special dot index of words at I is equal to -1. So whenever the index of method checks for something, if the value exists somewhere, it'll never be -1. But if the value just doesn't exist, it goes to -1 on its own. So that's what we're after. And if the value doesn't exist, this dot special dot push words at I. And once we have stored the special word, what we need to do is also append this value into the index array so that we can keep track of where the word actually should be. So all you have to do is this dot index dot push this dot special dot index of word at I. That should be all. We don't really need an else statement here. This is all there is to the compression algorithm, in fact. Let's try it out. let's make a compress object. So variable c equals a new compress. Let's feed it the inp. And then let's console log the stats out at least. So c dot index dot length. Let's see how much that is. That should be 754. That actually is correct. Let's see. Control find. Let's look for a space bar. 756. Yeah, that makes sense. Generally, there's like values that don't really matter in this text. So it does work. Let's also check all the characters. So special. Let's see if all the words we have are correct. And that is a let's get rid of this input. We don't really need it. Okay. So it did work. It has 209 entries. Okay. Well, now that we have that, let's print out some stats. So right in here, in the eat function, what we need to do is set the inner text of all the DOM variables that we have to a certain kind of value. So let's start with OP. No, let's not touch OP. OP is the final output, the decompression output. We are not there yet. Let's do OG, which would be the original value. So OG dot inner text is equal to a dot length, I guess. Yeah, that should work. I should definitely add a few more words to this. So let's do that. So original original size. Let's see if that worked. Huh. Oh right, we got rid of the compress. So let's do c.eat inp. Let's see if that worked. And it worked, yes. Let's keep going though. The next thing we want to do is the NOW, which is the number of words. Inner text is equal to, well, this dot index dot length. Let's add some text to that as well. Let's also check for all of these, because we might need a few formulas like making the percentage and stuff like that, but this is just for our convenience. The compression's already done. Next is the decompression. But let's get the stats out first. So I'm just gonna fast forward. fs dot. We should also add all the characters in our special array and add it to the index size. So let's do that. Let's make a variable called size, and then let's iterate through the specials array. So this dot special dot for each. Let's do word size plus equals word dot length. Hopefully that should work. And over here, all we need to do is size plus index length. That should do something. Okay. So I made a mistake. All of this till here, or yeah, till here for now. Let's put it outside. And this special dot for each thing, let's put that outside as well. And now it looks more realistic. So for total reduction, all you have to do is subtract the final size with the total length of the A string thing. So let's do that now. Always do A.length minus the size, the final size, or else you'll get a negative number because we are compressing it after all. And then for trp.inner text, all we need to do is, well, I actually do want to convert this into a round number basically. So let's do that as well. Total reduction percentage. The first thing we need is a math.floor. And then inside of the math.floor, we need a size plus this dot index dot length. So that's going to be the first part. And let's multiply this by 100 and divide the entire thing by a dot length. Does that work? Yeah, it does. But math.floor isn't working for some reason. Let's check that out. So let's put all of this in a bracket. Yep, that worked. And then let's add a percentage sign in front of it as well. And that should be good for the compression part. Let's do the decompression. That's going to be fairly simple actually. So all you need to do is make a function called decompress. And this will have a function in it, which will be called well, this function will take a variable, which will be the compress thing. What we need to do in here is map everything out. So let's make a variable called text, which will be the entire text. Set it to an empty string. Let's do a dot index dot length because we are passing the compress, so it's going to have an index and the index dot length, and we need to just traverse through it with let's just go with I guess. All we need to do in here is let's make a variable called x and let's add a dot special at I. So what we're doing here is we're looking at all the indexes and taking the index value and finding where it is in the special and seeing what word exists over there. And what we need to also do is add a spacebar manually. Let's do text plus equals x. Let's see if that worked. So with the variable c, let's make a variable d called new decomp. And now let's feed decomp the c. Let's also, in the function that I won't name, let's return the text. That way we'll have an output that we can see. And let's actually also just directly set it. I don't want to console log this stuff. Let's set it to OP's inner text. So OP dot inner text is equal to. It's not working. Let's see what's wrong. A dot index. Oh, not a dot index dot length. It's just a dot index. Okay, so as you can see, most of the words should be exactly where they are. Let's come to CSS and just do comma dot op so that they both have the same kind of styling. And they should be exactly the same. What else can we do with this? I'm hoping nothing else. But this was compression. If you liked this video, just subscribe. Actually, yeah, let's just cut it off right here. I wanted to do an announcement, right? I made a blog thing in like 12 hours. It was a challenge to myself, and I'm going to be uploading content over there. It's going to be basically documentation for my videos and a few other topics that I want to cover, like stuff that I cannot cover in a video only because I do it without like a script. And sometimes I just keep forgetting the main stuff, and I'm really not a good teacher right now. I will be someday, hopefully. So yeah, if I miss anything, if I say something that I didn't mean or something like that, it'll all be referred to in the blog. I'll link it. I don't really have a domain right now. I'm just using Firebase. So yeah, I'll just link it in the description, and if you want help, you can go there. And I'll add a feature where if you really do want to ask me a doubt or a question, so that's something that you have about web development, Python, Arduino, whatever you want, you can leave me a message over there, and I'll definitely be able to help. YouTube has the issue of people don't want to leave a comment because it has their face and stuff like that on it. But for this, I'm going to try and not do anything that requires you to give your identity out. And I'm most likely not going to put a paywall in front of any content that I make unless I'm making it for someone else, of course. So yeah, announcement.